that 5 is a factor of 15. So then the next question asks us, is 6 a factor of 124,314,984? Is it?
Yeah.
How do you know?
Because there's a trick.
What's the trick?
You add like 7 or something.
How would you, what if you didn't know the trick? There is a trick, but what if you didn't know that there was if you didn't know the trick? How would you know if 6 was a factor of that? What can I do? What can I do in my calculator to figure it out?
Divide the big number by 6.
Just divide, right? So we'll just divide the big number by 6 and see if it goes in evenly. If it goes in evenly, it is a factor. Divided by 6. It is. Ooh, that's a big old number, but it goes in evenly because there's no decimal or anything following. So it is a factor. We know because factors, what are factors? What's the definition of a factor? You don't have to give me a technical mathematical definition. Just tell me, what is a factor? What are factors? What are the factors of 6?
12, 24.
Those are multiples. What are the factors of 6?
3, 2,
3 and 2 and 1 and 6, right? So what are factors? Things that you multiply to get a result, right? They're the two things you multiply. It doesn't have to be 2 though. Okay, so just like simple numbers, functions have factors as well. That's why we spent so long factoring quadratics. It's really, really important. But we did factor perfect cubes. We factored sums and differences of perfect cubes. But this is going to be a type of factoring for cubic functions when they're not perfect. So, in order to do this kind of factoring, we have to use division, long division, like old school 5th grade division. So real quick, we're going to go over some division vocabulary from 5th grade. Anybody remember what the outside number of this little setup is called? I know, 5th grade was a long time ago. Anybody remember? Any thoughts what it could possibly be? Okay, we'll start with this number. What is the answer to a division problem called?
Quotient.
Good. Okay, so we know one of them. Quotient. So now I need the outside number and the inside number. Any thoughts? Come on, y'all, at least have a guess. I know y'all know them. You just don't know which one's which. I don't care. Just tell me a name.
Root.
Oh, that is a good guess, but no. They both start with a D.
Divisible.
Close. There's a dividend and a divisor. Anybody know which one's which?
Divisor.
The divisor is the one on the out. It would be if we had it written as a fraction. If we had it written like a numerator and denominator, the divisor would be the one on bottom. The divisor is the one on the outside, and the dividend is the one underneath. All right, now we are going to just real quick, old school long divide this, because by the way, that's not finished. So I'm going to long divide this, and we're going to go through the process so that you remember it, so that when we do it with polynomials, you're like, oh yeah, it is just old school division. Okay, so I'm going to say, I know the terminology that you used to use in elementary school is how many times does 12 go into 27? When you ask that, what you're really wanting to know is what do I multiply 12 by to get as close to 27 without going over? Isn't that really what you want to know? So what do I multiply 12 by and get as close to 27 without going over? 2. Can't use 3 because 3 would go over, right? So then you multiply. 2 times 12, that gives me 24. What's the next step? Subtract straight down. Now, for the purposes of polynomials, instead of subtracting straight down, y'all trust me on this one. It will make your life easier. Let's just change the sign on the bottom number and add straight down. So I'm going to make it negative 24 and add 27 to it. What is 27 plus negative 24? 3. Gets the same answer, doesn't it, as subtraction? But it will make polynomials easier if you just remember, change the sign and add straight down. Okay, you'll see in a little bit. Okay, so now same question. What would I multiply 12 by to get as close to 37 as I can without going over? 3. Then I multiply. 3 times 12 is 36. Instead of subtracting, I'm going to make that 36 negative and add straight down. That gives me a 1. Now, since at the end of 5th grade, or towards the end of your long division, you learned to put a point and a 0 and bring that down and get a decimal. That doesn't work for polynomials. So we have to do the very first, well, not the first thing, it's probably the second thing. The first thing you probably learned to do was put an R, right? You put remainder 1.
Yeah.
But after that, in between that and adding a decimal, you learned that you could bring the 1 up here and then put the divisor underneath it. And you end up with a mixed number at 23 and 1/12. That's how polynomials are going to work. Whatever your remainder is, it's the numerator and the divisor comes over. That's it. Alright, so now hopefully a lot of our polynomials will come out even now. Alright, so we're going to divide this polynomial. The small piece is your divisor. It's going outside the house. The big piece is going underneath. Now, similar to what we did up here, where we ignored the last 7 and we just did 12 and 27, you do that on polynomials too. Disregard everything but the first term on the outside and the first term on the inside. So I have x and x cubed. So the question is, what would I have to multiply x by in order to get x cubed?
X squared.
X squared. So I'm going to put an x squared on top. And now just like we did up top when we multiplied 2 by 12 and got 24, I'm going to multiply x by x squared by both of these terms. So x squared times x is x cubed. X squared times 2 is 2x squared. They were both positive, but here's where that whole making everything negative, instead of subtracting, it's just easier. Make everything the opposite sign. So I'm going to make this minus x cubed and minus 2x squared. Now you add straight down. What happens to my x cubes? Those cancel. This becomes negative 7x squared, and everything else just drops down, just like 5th grade division. And just like we did on this problem, you start all over again. We figured out what do we multiply 12 by to get as close to 37. Now, same thing, ignore the plus 2, ignore everything after the first term down here. So what would I multiply x by to get negative 7x squared? Negative 7x. So I'm going to put that up here. And then multiply. So negative 7x gets multiplied by both terms. Negative 7x times x is negative 7x squared. Negative 7x times 2 is negative 14x. Change the signs of everything underneath and add straight down. What happens to your negative 7x's? Negative 2x plus 14x. 12x plus 24. And we keep going. We'll do it all over again. So now, what would I multiply x by in order to get 12x? 12. It's positive 12, so I'm going to put plus 12 at the top. Now you multiply. 12 times x is 12x. 12 times 2 is 24. Change these signs on everything underneath. So they're going to be negative. Add straight down. I get a remainder of 0. So I end up with x plus 2 is a factor, and x squared minus 7x plus 12. If you were to re-multiply these, you would be right back here again. Everybody okay? All right. Now in example 2, they wrote it like this, but which one goes outside? The x minus 3, that's the outside piece, or the divisor. I forgot to tell you guys on the first one, because it didn't need it, but you have to make sure that whatever your highest degree is when you're dividing these, you have to make sure that you have every descending exponent. So since my highest degree on this is squared, I need squared to the first and then a constant. So on that one that we did, the highest exponent was at 3. So you need to make sure you have 3, 2, 1, and nothing. If you don't, you put a placeholder. You put a 0 for that particular one. So if you'll look at the next one, I know the bell's about to ring, but if you look at this one, it has 4, 3, and then 1. I'm missing x squared. So whenever I plug this inside the house, I would put x to the 4th minus 2x cubed plus 0x squared, just so I have that placeholder. Otherwise, your numbers get all out of alignment. So it's just a placeholder. It doesn't affect anything except for making sure your numbers are lined up. Okay, we'll finish that tomorrow.